Hi, Math 1, Mr. Bruns here. If you didn't get a chance to watch my previous video on an introduction to graphing, I really encourage you to take a few minutes and watch that before you dive into this video here. But in this video, we're going to talk about graphing two variable inequalities. And I know I just said two variable inequalities, but I'm going to start off with a very simple inequality that looks like it only has one variable in it. And this is y is less than or equal to 7. Now, we've seen things like that, but usually it's got an x in it, and we just graphed it on a number line. But this is something that we're going to graph in the xy plane. And even though we don't see an x in there, because really this comes from that equation y equals 7 comes from y equals 0 times x plus 7 if we think of it in a y equals mx plus b. There is that x there, it's just a slope of 0 times x plus 7. We know what y equals 7 looks like. I talked about something very similar to this in the previous video. Here is y equals 7, but we're graphing y is less than or equal to 7. So I want to think about what are all the points that would make that a true statement. And again, there's an infinite number of them, and I'm going to start listing off a few, like 2, 7, because the y value is 7, and 7 is less than or equal to 7. And 8, 7. The y value is 7, and 7 is less than or equal to 7. But then I'm going to think about 3, 6. So the y value is 6, and 6 is less than or equal to 7. And maybe 8, 1. The y value is 1, and 1 is less than or equal to 7. And hopefully you can start to see that it's very easy to come up with lots and lots and lots of points where my y value is something that's less than or equal to 7. Well, how do I show that? That's the big question. How do I show all of these points that I could start thinking of where the y value is less than or equal to 7? And if we started to just kind of, pick apart a few of these points and plot them, we would see, okay, so here's 2, 7, and here's 8, 7, and here's that point 3, 6, and here's that point 8, 1, and here's that point 4, -3. And all of those points are make this true because the y value is less or equal to 7. How about if I were talking about the point 2, 10? Well, this y value is 10, which is not less than or equal to 7. Here's 2, 10 way up here, and that does not work. In fact, you can look on the graph, and at really any point up here would not work because my y values are greater than 7 and would not make this a true statement. So just by kind of picking a few points, we can start to see, oh, I think anything that's going to make this true is going to happen on this side of the line. And so now we're going to make some connections to what we did last week, where we talked about inequalities on a number line, where we would find a boundary point, and then we would test a point, and we would send the arrow one way or the other based on which sides of that boundary point made our inequality true or false. And so now, instead of having a boundary point, like x equals 2 or x equals -4, now we have a boundary line. And eventually we'll get to a boundary curve. So my boundary line in this case was y equals 7. And so I graphed y equals 7. And then all I need to do is I need to pick some point that's on this side of the boundary line, and then I need to pick a point that's on that side of the boundary line, and let's test those points to see if I get something true or false. And since we found something true on the bottom side of this line, that means I shade everything underneath. That's indicating that any point in this shaded region will make that inequality true. All right, so let's try another one. How about we try y is greater than 1. So we know what that line y equals 1. That's my boundary line in this case. However, we want to be careful about this because if I think about my boundary line of y equals 1, does the point 3, 1, does that make this a true statement? Doesn't, because this would say that my y value of 1 is greater than 1, but 1 is not greater than 1. And yet the point 3, 1 lives on the line y equals 1. So just like when we were dealing with number lines, where sometimes we would use a closed circle, a closed dot, filled-in dot, to indicate that I'm including the point, or I would use possibly an open dot to indicate I'm not using that point. This one would be like less than or equal to. This one is just greater than. Instead of drawing my line y equals 1 with a solid line, what we do is we draw it with a dashed line. So this is equivalent to having an open dot. So this is still my boundary line, but I'm not including the boundary line in my solution. Okay, so I drew my boundary line. In this case, I used a dashed line to indicate I'm not actually using the line itself, because I don't want to be greater than or equal to. It's just strictly greater than. And now I just need to pick a couple of points on either side, 1 point on one side of the line, 1 point on the other, to figure out which side I'm supposed to shade on. Now, some of you might be able to look at this and say, y is greater than 1. I know which side to shade on. That's great. That's fine. But we want to get in the habit of picking a couple of points. Okay, so I'm going to try the point that's down here. This is the point that is 4, 0. And if I put 4, 0 into here, really all I need to do is test the y value, 0 greater than 1, and we see that is false. Doesn't work. Okay, so this did not work, 4, 0. And then I'm going to try the point 1, 5. 1, 5 is something up here. And let's see, I put the 5 in for the y. 5 is greater than 1. Absolutely, that's true. And so yes, hooray, that worked. And so now I figured out which side I need to shade on. I need to shade on the side that had the point 1, 5. So I shade everything up here. So I have this line drawn with a dotted line. So I'm not including the line itself, but I'm including all the side things that are shaded above that. All right, let's go with y is greater than 2x plus 1. All right, so this one's going to be a little harder to test values. They're not as simple as just y is greater than 1. But the first thing we're going to do is we're going to graph this line. We should know how to graph that line. It's in the form of y equals mx plus b. So I have a y-intercept of 1, and I have a slope of 2. So I rise 2, and I go over 1, rise 2, over 1. And again, I'm sorry I'm not doing them. These aren't great-looking graphs. I'm not using graph paper. Just trying to make this sketch really quick here. And so am I going to use a solid line or a dashed line? That's kind of the next question I ask myself. Because this is strictly greater than, not greater than or equal to, I'm going to use a dashed line. It's kind of like having that open circle on the number line. So a dashed line to indicate my boundary. And now I need to pick a couple of points to test. Okay? You know what? I'm going to try one of my favorite points. That's the origin 0, 0. I'm going to test 0, 0. And then I will test this point over here, which is going to be -1, 6. Okay, 2 points that are clearly on one side of the line or the other. So I plug in the point 0, 0, and we get 0 is greater than 2 times 0 plus 1. 2 times 0 is 0. So is 0 greater than 1? That's false. All right, so 0, 0 apparently didn't work for me. Now I'm going to try -1, 6 just to make sure I didn't make a mistake on that previous point. So 6 is greater than 2 times -1 plus 1. 6 is greater than -2 plus 1. Is 6 greater than -1? Absolutely, that's true. So in this case, I'm going to shade on the side that has the -1, 6. So that's above the line here. And so everything here gets shaded in. Again, I'm not including the line. That's a dashed line because that would indicate that y is equal to 2x plus 1, but we just want y to be greater than 2x plus 1. All right, so now let's kind of take it to the next level here, and let's look at y is less than or equal to 3 to the x. Now I'm looking at an exponential function, and we haven't done a lot of graphing of exponential functions, but you should know what the general shape of an exponential function looks like. And And frankly, that's all we really care about at the moment. You get that general shape, that general idea. We should know where that starting value is. If you let x equal 0, this becomes 3 to the 0. Your y value is going to be 1. And most exponential functions just have this shape right here. And if you're unsure, you can use a calculator to help you out if you have a graphing calculator at home. If you don't, you can use Desmos.com or any other sort of graphing calculator utility that you can find online. So it's really easy to find something that will help you graph something if you're not sure what this is going to look like. Now, I just drew a solid curve here. I did not use a dash curve. Did I make a mistake, or am I okay with that? In this case, I'm okay, because this is less than or equal to, so I'm thinking about y equals 3 to the x as my boundary curve, and since it was less than or equal to, I can draw it with a solid curve, okay? So now again, I'm just going to pick a couple of points and see which ones make this true. I love picking 0, 0. That is an easy to plug in point. And then again, I don't know, I guess I'll go up here with, this is going to be 1, 10. Pretty confident 1, 10 is on that side up there. If you want to pick an easier point to test out, you can do that. That is fine. All right, so here we go with 0, 0. See if we get a true statement or not. I put 0 in for y, so 0 is less than or equal to. 0 in for x, so 3 to the 0. Let's see, is 0 less than or equal to 3 to the 0 is 1? Anything to the 0 is 1. Is 0 less than or equal to 1? Sure is. That's true. Great. All right. Let's try 1, 10 and see what happens. So when I plug in 10 for y, 10 is less than or equal to 3 to the first power. X is equal to 1. So is 10 less than or equal to 3? Nope. That's not true. And so I've just found I do not shade on the side with 1, 10. I'm going to shade on the side with 0, 0. And so everything below this gets shaded in. Everything below the curve gets shaded in. This curve continues moving on forever and ever and ever in both directions. We just are showing kind of a part of it. All right, one last example. Let's try y is greater than 3 times 0.2 to the x. All right, y is greater than 3 times 0.2 to the x. My boundary curve is y equals 3 times 0.2 to the x. And if you're not sure what this looks like, yes, this is an exponential curve, and there's your a value, here's your multiplier. I went ahead and I already graphed this on my calculator. I'm going to put that here. So notice this is an exponential curve, but it's curving in the other direction. It's going down. This is a decreasing curve instead of increasing as we move from left to right. So again, if you have a graphing calculator, that's great. If you want to use Desmos or some other online graphing utility, that is perfectly fine. But I see that I have this curve that goes down. Now, I am not going to draw this with a solid curve because I notice that this is y is just greater than, not greater than or equal to. So my curve, my boundary itself, is a dotted line like that, or a dotted curve. So once again, I'm going to pick a couple of points. I know you might get sick of using 0, 0, but again, I think it's the easiest thing to plug in there. And then I'm going to try 2, 7 lives up here. So we go 0, 0. We're going to test that. 0 is greater than 3 times 0.2 to the 0. That says 0 is greater than 3. Anything to the 0 is 1, so it's 3 times 1. Is 0 greater than 3? False. Not true. All right, let's try 2, 7. See if we get something true on this side then. 7 is greater than 3 times 0.2 to the second power. 7 is greater than 3. Let's see, 0.2 times 0.2 is 0.04. And 3 times 0.04 is going to be 0.12. Is 7 greater than 0.12? Sure is, that's true. So we're shading on the side that has the 2, 7. I'm going to shade everything up here. So my solution is not including the dotted curve, but everything shaded above it. All right, so hopefully that helped you and you're able to figure out how to tackle your homework along with checking out the examples that are in the parent guide. And if you have any questions, as always, send me an email, stop by XBlock, let me know.